topic tonight. Alan?
Thank you, Radmila. So I'm going to tell you a little bit about my research and some of the things that I work on. I'm going to tell you some things about stories that are written in stone. So everybody says there's nothing that's written in stone. However, as a geologist, everything is written in stone. The entire history of the Earth is written in stone. So before I get started, I'd like to introduce you to my esteemed co-author, Sheila Silica. And I brought Sheila along and her 1,000 other friends. And these are my co-authors, and these are my colleagues in my research that I'm doing. So you'll hear the story of Sheila and how we use Sheila to be able to understand what's going on the surface of the Earth in the past and how we can use that to understand the future. So we're going to start out, we're going to talk about the continent of Australia, and we're going to talk specifically about the southeastern and central eastern shorelines of Australia, basically from just south of Sydney to just north of Brisbane. So this is where I met Sheila when I was working in Australia in 2012 when I was down there for 7 months on sabbatical. And Sheila actually started off as a piece of gneiss and a metavolcanic rock on the Broken Hills area. And she hung out in the Broken Hills for quite a while, and then erosion happened and she got broken off and transported down a river and put into a place called the Hawkesbury Sandstone. The Hawkesbury Sandstone is this very large sandy deposit that amounts to an old coastal plain with sand dunes and river channels. And this is an example of the Hawkesbury Sandstone down below, just outside of Sydney. So she spent the next, probably 598 or 99 million years just sitting in the Hawkesbury Sandstone, waiting for something else to happen. And then, lo and behold, erosion happens. Waves come up, rivers come up, and she got chipped off of the Hawkesbury Sandstone and introduced into the ocean, where she skipped up the coast from New South Wales up onto Bondi Beach. And she was happy on Bondi Beach for a while until she realized that she was constantly getting stepped on by the Australian megafauna. So wombats and kangaroos that are the size of cars and buses, along with a thing called the demon duck of doom, which when you see some of these creatures, you understand where we get our alien movies and where we get our dinosaurs from. So she decided to leave Bondi, and she headed her way north, and she ended up bouncing back and forth on these little beaches, enjoying life as a person who just sat on the beach for a while and then moved on until she got to Surfer's Paradise. Surfer's Paradise is just across the New South Wales and Queensland border, where she picked up the art of surfing, and she started to learn how to ride the big waves. And the big waves were the things that really excited her and moved her around. So back in 2012, a cyclone hit Surfer's Paradise, and it left this very large erosion scarp on the beach. This scarp is about 8.5 feet tall. It removed a significant amount of the beach, and Sheila and all of her friends, if they would have been there at that time, would have been tossed back into the water and moved along. So she continued her journey up the coastline, surfing her way along on the big waves, until she got to Fraser Island. And Fraser Island's the world's largest sand island. It's about 125 miles from the northern end to the southern end, and it's nothing but sand dunes. And these sand dunes go to about 240 meters tall. It's some of the largest coastal sand dunes in the world, and it happens to be a UNESCO World Heritage Site for these sand dunes. Just so happens that even though that's the focus of the UNESCO World Heritage Site, they haven't really been studied. So she hung out on the beach for a while, and then she realized that this beach was getting a little bit crowded, and by this time, she'd gotten a little bit smaller from being bounced around in the waves, and the wind picked her up and moved her inland and deposited her on a sand dune. And there she sat until myself and my research colleagues from the University of Queensland in Australia came along and picked her up and invited her to join our research project and have her tell us the story of what it is that she's experienced. So what we actually do in order to understand what's going on in the past is we look at different types of environments that are on the surface of the Earth today and use what's going on the surface of the Earth and the processes that are interacting to be able to reconstruct what's going on in the past. It's called the present is the key to the past, the principle of uniformitarianism. It's one of the things that all geologists live and breathe by. So we have all these modern environments, things like eucalyptus forests, large sand blows, deep gullies within sand canyons, big open sand dunes, coastal landslides, and little erosion scarps on beaches. And we can look at each one of these and understand the processes and the energy that created them, and then look into the geologic record and go from there to try to build up a story of what happened at any individual place. Because the physics hasn't changed on the surface of the Earth. So the wind is going to continue to blow as the wind has blown, and it's going to continue to move grains of sand at the same types of rate. So we use a system called ground penetrating radar. This sends radar waves down into the subsurface, and we look at the responses of that to try to understand what the environment used to look like. And then we go in with a whole bunch of other techniques like geochemistry and optical stimulated luminescence dating to understand the details of the climate and the details of the timing of that it was deposited to be able to build up these stories. So we sat down and listened to what Sheila had to tell us, and she told us there was a great place to go, and this is called the Wongi Sand Blow. The Wongi Sand Blow comes from the destabilization of these sand dunes. Vegetation breaks down for some reason, possibly fire, and then the wind picks up and accelerates over that patch of bare sand and begins to move the sand around. This is a very large bare patch of sand. It's about 1.5 kilometers long from north to south and about 0.5 kilometers wide. And this face is about 9 feet tall. And this sand is moving basically from the left to the right on this image. So we took our ground penetrating radar, ran it over this, and we came up with an image that looks like this. A bunch of black and white squiggly lines. So how in the world do we pick out something on this that helps us to understand what climate used to look like? Well, we reflect back on what we're seeing that looked like this, and we compare it to what we see in the subsurface. And we then use that to reconstruct the past environment. So we do this by basically doing the old-fashioned thing of taking a crayon and drawing on it and interpreting what we see. And as a geologist, this is what I see when I look at this. I see 3 different dune sequences that are related to large parabolic dunes from when the island was totally unvegetated. And then I see 3 sequences of when this blowout was active in the recent past, and then one, blowout number 4, all the way up at the top, is that 9-foot advancing wall of sand that you could see on the previous picture. So by looking at this, we can kind of get an idea of what happened, that at some point in the past, the landscape destabilized, the vegetation broke down, and sand started to move. And it started to deposit this thing called blowout 1. And then that stabilized for a while. It started to develop a soil horizon on it. And then the landscape destabilized again, and this time it stayed destabilized and created everything blowout 2, 3, and 4, creating this very large 1.5 kilometers by 0.5 kilometer wide feature on the landscape. That tells us a lot about climate. So if this landscape was destabilized by fire, which we have some evidence for of charcoal in the sediments, then we have an idea that the landscape was probably a little bit drier, may have been a little bit windier in order to move all of that sand. So we can then relate that back to things like the ice cores from Greenland and Antarctica to try to reconstruct climate and understand what's going on with things like the subtropical convergence zone, which occurs in Australia, that bounces back and forth to the north and the south over this area as we go from glacial to interglacial time period. Well, okay, this is all well, fine, and good, but what does this really tell us about what's going on? So as we've looked at all of the things that Sheila and her friends have told us, we've come to figure out through doing some dating of these sand grains that we have about 750,000 years of record archived in these sand dunes. Every place that you see a red star across the top relates to a period that we've dated for active movement of sand. The curve shows a proxy of sea level. So when it's high, sea level's high. When it's low, sea level is low. The low periods are also colder and drier. They're the glacial periods. The high periods are warmer and wetter, and they're the interglacials like we're in today. So we're trying to understand exactly how these periods of activity on Fraser Island relate to climate, and what can that tell us about what might happen to climate in the future. 2 minutes? Not a problem. So, what can Sheila tell us? Besides, Fraser Island's a great place to go, lots of really interesting things. She can actually help us understand when the dunes were active, which suggests drier and windier conditions. We might be able to use that to relate to sea level and how it relates to changes, major changes in atmospheric circulation. We also know that humans have been in Australia since about 65,000 years ago. We're trying to get a handle on what their impact is on the landscape. They started early using a thing called fire stick farming, which was actually burning the landscape to be able to clear the landscape to be able to grow crops. We have evidence of increasing rates of fire over the past 45,000 years. So there may be some relationship, at least in this very short term, past 65,000 years, that may relate to the human influence on the landscape. We can also try to relate this to the extinction of the megafauna. So these things like the demon duck of doom, the wombat that's the size of a Volkswagen Beetle. Were they hunted to extinction by humans, or were they done in by climate change? It's a discussion that's ongoing in the literature in Australia. And we can take a look at past climates and their environments and see how we may be able to understand what's going on presently. So, I have an army of people who have helped me. Faculty members and Ph.D. students from the University of Queensland, from the University of Sunshine Coast, the Australian Research Council, University of Massachusetts at Boston, University of Queensland, and the University of Sunshine Coast all funded this research. It's an ongoing research project, and in fact my Ph.D. student is currently in Australia collecting more data on this project. And then the Bacella people, the traditional owners of Kagari, which is the Aboriginal name for Fraser Island. Thank you.
Thank you, Alan. Questions? Al for Alan.
That's great, Alan. Thanks. I'm curious of the northern-southern hemisphere relationship. The glacial periods, were they the same in both hemspheres? Or was there some relationship between them? And how do you relate the glacials to Australia?
So Wally Broker, one of the early climate scientists at Lamont Doherty, put forward a hypothesis that was called the bipolar seesaw, and put the fulcrum right at the equator and said the northern hemisphere and the southern hemisphere basically operated independently of each other, that they were out of sync. Based on ice cores in Australia or Antarctica versus ice cores in Greenland. Subsequent research has actually pushed that fulcrum all the way down to the Southern Ocean. Southern Ocean completely circles Antarctica and actually thermally isolates it from the rest of the world. So the southern hemisphere and the northern hemisphere are pretty much in sync once you get north of about 50 degrees south latitude. There is a little bit of an offset, but not significant, and not that we can really resolve within the age dating technologies that we have.
Nancy?
First of all, thank you. That was great. When you went from your graph of what you called the squiggly lines to the next one where you said, this is what I see, which looked rather different, are you seeing that from internal information that you're gathering, or are you taking, external, we know this happened then, so the dune must have blown over and that type of thing?
That's purely a visual interpretation based on what we see in that individual record. So within this record, you can see areas where there's a large feature that's there that's buried. And by kind of piecing these things together, by looking at which comes first in the spatial relationships of these things that we group together, we can understand relative timing of that then looks like something like this, where this blowout 1 had to come before blowout 2 because it's underneath. It's a little hard to stick a pile of sand underneath the sand that already exists. So it's all based on spatial relationships and finding these large bounding surfaces that kind of create a unit.
One more question?
Great. Thank you for that great story with Sheila. How do you untangle the things due to climate and erosion versus plate tectonics? Because Australia wasn't where it is now back then. Because these are, well, one of your figures goes back 500 million years, right? Or 600.
That's thousands of years.
Okay, never.
That's hundreds of thousands of years. So I work on the timescale of 2 million, roughly 2 million years, and the data that I showed was within the past about 750,000 years. So in that timescale, plate tectonics impacts in Australia is very negligible. We have to go back considerably further in order to have plate tectonics be a factor on it. Unlike here in San Diego, where we have active faults going on that are actually changing the landscape very significantly due to earthquakes and plate tectonics. That's not a factor that we need to worry about in Australia.
In the interest of time, we will move forward. I also have questions for you, but let's hold them until the end of the talks so that we can interact with all. Thank you all. Bye.